Welcome to Data BS, a show dedicated to tackling the big questions impacting the world of data and ML/AI without any of the BS. My name is James Winegar. Each week I sit down with guests from across the data ecosystem to unpack how they're shaping their businesses or the businesses of others through the real-world application of data engineering, ML/AI, infrastructure, analytics, and more. No fluff, unfiltered, but slightly edited to remove noise. This is Data BS. Let's get into it. Welcome to Data BS. We're here with Sam Kahn. So, Sam, you want to tell us about you? And
Thanks for having me, James. Yeah, my name is Sam Kahn. I'm VP of AI and Data Science at TICKR. I'm also a AI Research Fellow at UC Santa Cruz. Yeah, so my background is about 13 years in machine learning and what now people call artificial intelligence, right? My journey started as a physics major at UC Santa Cruz. And then I got an internship at NASA working on recurrent neural networks for energy forecasting. And then that led me to a graduate degree at UC Berkeley. After UC Berkeley, I worked at Salesforce.com for a little bit on their customer intelligence team as a data scientist. And then I helped found a startup called MarketSpace, which was a natural language processing startup. And that led me to where I am today. TICKR acquired that startup, and I've worked at TICKR for 8 years. And we specialize in delivering AI and data science solutions for the consumer packaged goods space, which you might hear me refer to as CPG, and the retail space as well. And you might not know what a CPG is. A CPG is a company like Lay's potato chips or Coca-Cola, or one you might have heard of is called Procter and Gamble. And these are companies that literally usually take some item, put it in a package, and sell it at the store, right? So we build data science and AI solutions to help those consumer packaged goods companies make their business operations more efficient, save time, and save money. Really, the promise of AI and data science actuated, if you will.
so, what's TICKR's core value proposition then? Like, what is it different? How does it differentiate itself from its competitors?
When I think of our competitive space, I honestly really can't think of anyone who has our level of expertise in consumer packaged goods through our business development team and our data science team. And then more specifically to what I do, we have a very deep level of AI and data science expertise. And we've really focused it into the consumer packaged goods and retail space. So we've learned over time what are the real pain points these companies are experiencing because we're talking to them, we're deploying real solutions for them. And as far as I know, we're the only company in CPG and retail focusing on AI and data science in this way.
When I usually think about companies providing data solutions to CPGs, it's usually more as a vendor, right? Data
Hmm.
vendors. And then
Yeah.
you're also partnered with those data vendors, right?
Yeah. So like the challenge we faced initially is we didn't have data, right? How do you do data science without data? And part of our strategy over the past several years has been to partner with data providers like companies like Nielsen, IQ, or Numerator, or Data Assembly. And their business model is to sell data to these consumer packaged goods companies. So this data often is simply sales data. Like the retailer might be collecting sales transactions at the cash register, right? And a lot of these data providers have deals with the retailers to collect that data, but then they sell that data to the CPGs for millions of dollars, right? Sometimes many millions of dollars. And they see some of them do have data science teams like Coca-Cola, right? They have a very well-known data science team, or Walmart, right? But a lot of them do not, right? So they buy this data and they don't know what to do with it. So then we partner with the data providers or the CPGs to build repeatable AI and data science solutions to help them get more out of their data. These solutions could be AI-driven business planning, product categorization, forecasting, but now we're not just doing forecasting. Our forecasting is what we would call AI assisted, right? So we have language models, improving our forecasting models and making decisions on how to make essentially modeling decisions at scale as a human would, but deploying it at scale.
So I think like you've worked in the NLP space for a very long time, right? I
Mm,
think as long as I've known you, you've been doing NLP, right? So
yeah.
at least 10
Hmm.
years.
there's always been this promise with NLP that we're going to be able to take all this crazy text data, do
Mm-hmm.
more with it. And then suddenly
Mm-hmm.
ChatGPT comes out and we start
Yeah.
talking about GenAI and how
Mm-hmm.
GenAI enables this new capability that
Yeah.
we've been trying to work on for a long time, but it
Mm-hmm.
got to a
Mm-hmm.
certain point of effectiveness.
Yeah. Yeah.
So my gut feeling is that like these new capabilities actually provided like TICKR new market opportunities that didn't
Mm-hmm.
exist before, because like
Mm-hmm.
you can do this automated decision making type
Mm-hmm.
process.
Mm-hmm.
First thing is, what are the most common use cases for TICKR in the
Mm-hmm.
CPG space and
Mm-hmm.
retail? And then can you talk about examples of previously unsolved problems that you can address?
I think because we're working with very large enterprises, a really common use case is forecasting, right? It's a very classical data science use case. They want to understand and look a year, maybe even further into the future and understand how their business is going to do. And I'd say that's probably the most common use case we hear. But now with generative AI and the power of both the commercial frontier models and the open source models, there's a whole new space of problems we're also solving. Those problems would fall into hierarchical product categorization, taking the data from these large data providers and improving it so you can use it for downstream data science applications. A lot of the data comes in super messy. Maybe they're using OCR to scan receipts. The language models can go in and fix that data. I think some of the problems that these language models have unlocked is it boils down to essentially a level of reasoning and what might be called zero shot capabilities at scale, right? These models can make really human like decisions at scale, so then you can deploy little nuggets, if you will, of reasoning in different places of your application that we couldn't before. One solution we've deployed and we're actively working on with the customer is something we call generative predictor search. And a problem with forecasting and ask from our clients is we have all this data, it's internal to our business, right? We're tracking our units sold, our sales, our promotional price, all this stuff that we control. There's all this data out there on the internet, and not just on the internet, just like in the Federal Reserve Economic Database, right? In the news, that wouldn't it be great if we could go get that data and integrate it into our forecasting models? But it's really not scalable to do for hundreds of thousands of different products across thousands of different categories, right? But these language models, if you train them to search, if you train them to search the web or search the Federal Reserve Economic Database, they can go look through all this data and make decisions as a human would on what they think could be predictive for our models. And you might ask, why don't you just test every single time series you can find on the web and put that in your model? Well, as you know, James, like spurious correlations, right? You're gonna find that the price of wood in Saskatchewan, and maybe you could reason through some reason why this could be, but it's very predictive of the sales of my Lay's potato chips. And there you could maybe find a causal mechanism there, but it's likely not the case and it's likely spurious. And the language models can look through that data and they know that that is likely a spurious correlation. So they essentially they help us do high recall search and then bring in a few potential covariates to help our forecasting models.
You're using like the LLM or the Gen AI capability to do a thing that a human would have normally had to have gone through,
Mm-hmm.
but people are not good at looking at hundreds of thousands of things over and over again.
Exactly, right. And to be honest, like yeah, a human would have to do it before, but most of the time a human wouldn't do it because it's not
It's
possible,
not
right?
feasible,
Yeah, not
right?
feasible.
Yeah, the amount of time it would take to do this across every product category and things like
Mm-hmm.
that, which I think is also important to talk about, like
Mm-hmm.
hierarchical product categorization. Like,
Mm-hmm.
why is that a hard problem for these CPGs? Like,
Yeah.
I've worked in CPG, so I've seen it, but
Essentially, hierarchical product categorization is hard for the CPGs. Like I was saying earlier, they buy this data from the data providers, and the data providers will categorize it into their own categories. But those categories, 99% of the time, are totally useless to the CPGs because they bucket their data in, ways that make sense for their business. It comes down to, one, them not actually knowing how to recategorize this data at scale. It really just comes down to like extreme multi-class classification, right? And using the language models as either few-shot learners or fine-tuning them and then doing few-shot learning. So it really comes down to they just don't know how to do it.
Let me see if I can reframe it.
Okay.
Like in a different words, you tell me whether or not you agree with me. So these models have taken what would have required an expert, a CPG person, to go across more work than they possibly could ever get done in their lifetime, and provide the ability to do this classification of different toilet papers or toiletries. But maybe that doesn't make sense because of how they do their manufacturing. Like Procter and Gamble's got, I don't know, tens of thousands, hundreds of thousands of products that they sell, categories of brands, etc. And so being able to do that across their entire portfolio and across their different retailer spaces, right, or consumer spaces, helps them understand what is even going on.
Yeah, it helps them understand what's going on. It helps them group their products so they can look at sales metrics in the ways they want, right? And then also very important, the language models, because of their ability to look at a few examples and predict very well from those examples, their ability to meta learn, they can change their definition of product categories very easily, right? Before, this would require a full retraining of like a BERT model, right? But they can change their product category definitions. And with our AI systems, they can then send those new categories to our system. And then you can project the data or the products to a whole new set of classes, right? And that was not possible before. And that is very exciting.
Yeah, so it's dynamic too. It's not just the process of doing the categorization. It's being able to evolve the categorization as things change in the market, which is happening all the time. But you've talked about it already, but like data is messy, especially for these CPGs, because it's very distributed across like all the different retailers, their direct to consumer, e-commerce type platforms. There's tons of stuff that's going on. And you got receipts and they get OCR'd, or you got structured data maybe coming from certain places. Like there's like with Walmart, for instance, you're going to get like an EDI feed or something like that. But from, I don't know, Trader Joe's might not. They probably do. But some place is going to just do orders. And then, you have like this procurement process that gets managed, and you have to figure out like, did it actually sell? Like coupons are a very complicated thing in the space. Like, how do coupons get utilized? Where should you even deploy a coupon? Why should you deploy a coupon? All these types of things. Like from TICKR's viewpoint, my understanding is that you're doing a lot of automated data cleansing, because there's really no practical way to do it across all these different data providers that you partnered with. Do you want to talk me through what's going on with the data cleaning side?
I think the easiest example would be the one you mentioned, the lossiness in OCR, basically. So somebody buys something at a store, right? They get a receipt. And a lot of these data providers, their business model is to essentially pay people to take a picture of their receipt, OCR it, and they collect that data. And then the CPGs buy that data from them so they can see what people are buying in the store. But there's this process of OCRing the data that either the OCR is bad, or some of the retailers, they don't really want that to happen. So they make the names of the products or the descriptions of the products, or maybe even the UPCs, they make them ambiguous. For downstream applications like forecasting or other data science applications, this missing data that kind of gets collected through the OCR process really affects the data science models. We felt like this frontier of generative AI could look through this data and maybe clean it up, and we'd get better downstream forecasting results. So that's what we ended up doing. And where did that intuition come from? Because it basically came from the fact that as a human, we could do it, we could clean it. So then if a human can do it, but it's not scalable, a language model could probably do it. So essentially, we have a few different types of language models looking at this data and inferring what the true product name is. And how does it infer that? We ground it with essentially an external data source of real products, and then it can reason over that data. So it's basically like a RAG pipeline, right? Like a new product comes in, you look for potential similar products, and then you have the language model reason either the non-corrupted data, or it will tell you it can't figure it out. Because we also don't want false positives, right? Because that would corrupt the data as well. So
yeah, which means you also have a methodology to bring the feedback loop in, which is super important for like these Gen AI use cases. Like,
yeah,
I don't have a high amount of confidence in what I just gave, and
yeah,
so I'm
mm-hmm.
gonna create a system in place within the TICKR kind of AI
Mm-hmm.
platform
Yeah.
to get that
To
human feedback loop
yeah.
in.
You don't. It depends, right? Like if you have training data, right, and you have data you can benchmark the model against, right? You don't. If the system you build performs well on those training metrics to like say like the accuracy of UPC recovery, right? Or the number of UPCs recovered, right? If you have enough training data to like measure the performance in your system, you don't always need a human in the loop, right? And we do use a human in the loop for some of these applications, but for the most part, we calibrate the models to only predict when they're never be 100% right, but when we believe that they'll be 99% right. And what we find is it still helps the downstream data science application, so you can get more accurate business planning, product categorization, if you will, because if you have corrupted data, you don't know what the product is, you can't categorize it. So
Which then breaks all your forecasting use
yeah,
cases.
yeah, which breaks the forecasting use cases, or it breaks the categorization use case we were talking about earlier, right? Because the model won't know what the product is.
Let's get back to search,
Mm-hmm.
because like you talked about like the wood in Saskatchewan and then Lay's potato chips and things like
Yeah.
that. Let's like, how does the TICKR platform prioritize those as external data points that it's looking
Mm-hmm.
at?
Let's say we want to forecast Lay's potato chips, right? So we'll have a bunch of internal metrics, right? This usually comes from the CPG, like sales, maybe the promo price, the price, base dollars, ACV, feature display, all these metrics that CPGs track in stores, right? And then we don't need a language model to search over that data. The space of covariates is pretty small, right? Anywhere between 20 and 100, right? But the space of external data, you could maybe argue is infinite or close to it, right? So that's where the language model comes in, searches for that data, and then it returns it. And it returns data it thinks could be predictive of Lay's potato chips. But we're not just going to put that data in the model, right, and just fire it off and go. We did a lot of research to see if this actually worked and helped our models. I think the number off the top of my head is we got a 16% reduction in error for our forecast models by doing an external covariate search with the language model. And with that in itself speaks for itself, right? Like you can get a 16% better like forecast, be able to plan better for your business. And that 16% is driven by statistical models, right? So we actually test the forecasting models out of sample data. We see if it actually improves, and then we'll deploy it. There's cases where external data will not help a model, right? Sometimes you don't have that much data. You need to be very careful about how you do forecast. You don't want to overfit to your validation set, things like that. And you're doing this at scale, so you have to be very careful. So
what's one of the ways you manage being careful?
it's almost as you could almost think of it as a machine learning classifier, right? We bring our decision threshold to a point where we're sure that anything we put into the model we're correct about. So we err on the side of being careful, and then everything we do is tested. We would never deploy a model without testing how it does on out of sample performance, right? We're very careful not to do too many comparisons either. As we all know, you can get spurious correlations, even with the language model doing that high recall search and then whittling things down for us so we can integrate them into our model. We still need to be careful. And that is done through more traditional data science methods like out of sample performance.
Yeah, so you have just like traditional, like just basic statistics, right?
Mm-hmm.
That we've been doing
Mm-hmm.
for a long time,
Mm-hmm.
but you're pairing it together with Gen AI capabilities, NLP capabilities. And so we got a bunch of like time series data, a bunch of text data, basically,
Mm-hmm.
or
Mm-hmm.
very unstructured or very
Mm-hmm.
messy, etc.
Mm-hmm.
And you're bringing that all together. We've talked about covariate search or product search, etc.
Mm-hmm.
We've talked about different categorizations, and we've talked
Mm-hmm.
about forecasting. Are there any other
Mm-hmm.
use cases that you're really bringing together?
Yeah, I think a few use cases we've been working on with clients are automating the process of survey collections, right? Response coding, things like that. Pretty low hanging stuff for language models just to speed up that survey, that the process of running surveys, collecting data. We've actually done some really interesting research lately. One of our AI scientists on predicting the responses of surveys with the language models. So we collect a lot of surveys and then we ground the language models in historical survey data, and then we test whether it can actually predict like next year's survey responses, and we can see that we can actually get a pretty high level of accuracy there. This is like one of our experimental research projects. We're still exploring it, but it is pretty exciting because these models have a very strong level of expressive power and a very exciting ability to essentially mimic humans. There's still a long way to go. This like Cambrian explosion of use cases is like it's pretty amazing right now.
Yeah, the survey one's crazy to me almost. It's almost like you're doing a regression on
Yeah.
the survey, but then like is there like sentiment coming in from like PR sources and things like that you're
Is
also bringing into that
the,
or
so the survey so we went online and we found a bunch of surveys, I believe from some type of social work database, and we had the hypothesis that maybe if we collected enough longitudinal surveys, we could then hold out a few years of data at the end and see if the language model could infer how these survey responses changed, grounded on maybe current events, stuff like that. And it does pretty good. And it gets pretty close to answering the way the humans would. And of course, like this opens up a space of like concerns around bias and concerns around propagating harm and stuff like that. This purely is like a research project for us because we do have a lot of clients that do live in the consumer survey space, right? Because you consumer packaged goods companies, they run consumer surveys to understand how people view their products. So wouldn't it be great for them to be able to run a few surveys and then deploy it to a language model and then predict what the broader sample or population
well,
would say?
like another thing from a business decision making side, right? You could say, hey, the forecast is telling us because whatever recent events or whatever that we're
Mm-hmm.
going to have a downward trend in sentiment for whatever this product category
Mm-hmm.
is. So we can get ahead of that.
Yep.
And
Yep.
so, like now you're like, okay, yeah, I don't know, toiletries is probably not a good example because
Mm-hmm.
it's a
Mm-hmm.
necessity, but you can be like,
Mm-hmm.
oh, okay, like toiletries is a thing that we need to deal with because hurricanes coming through,
Yeah.
right? And like
Yeah.
we know that people are gonna be like, where's all the toilet paper? Because they're gonna buy
Mm-hmm.
all the toilet paper,
It,
right? And then that leads to a bunch of negative sentiment for like
exactly.
Procter and Gamble and all the different CPGs that sell toilet paper. And if they could just get ahead of that in terms of
Mm-hmm.
like, hey, we shipped 500 pallets extra toilet paper to
Mm-hmm.
Florida before Milton hit to make sure that people had
Mm-hmm.
supplies available during the recovery phase. Like, I don't know, some
The,
interesting stuff that
you could definitely protect yourself, right? I think, yeah, you could think of a lot of use cases, maybe a bad news cycle. How is consumer sentiment going to change from this? There might be some news cycles you might perceive like will really affect your business that won't, and there might be some that will. And having a language model take an objective look, grounded in real data, not just like off hallucinating, whatever it wants, right, is an exciting proposition for us.
how do you do against like the categorical variables? Because it's just like
Yeah,
this is more just me talking
yeah,
about
yeah,
like why I
yeah,
hate accuracy because like
yeah, yeah.
accuracy across like which buckets, and then you could also tie it into your hierarchical
Mm-hmm.
classification and
Mm-hmm.
like are you optimizing against your hierarchical classification as well?
This data was coming straight from the data provider, so
Okay,
we weren't doing any rebucketing of
okay,
that data. But yeah, no, I'm fully aligned on accuracy being a bad metric for I don't ever really use accuracy, but it's digestible, right? So like precision,
yeah,
recall, F1, those are the accuracies that or the accuracy is the metrics I usually use. So
yeah, colloquial accuracy, right?
yeah,
Like
colloquial
how
accuracy.
good, how did we do
Pretty,
relative to what we care about,
yeah,
right?
yeah, pretty good. So like the context of the prediction problem always matters too, right?
I think that's important too. It's like, what is your benchmark? Like, what are you comparing against?
Yeah,
Right. So for a lot of these problems that we talked about today, there was never really a person who could do it because there's just too many things to go
right,
through. Right.
right.
So it's like your baseline is basically like, does somebody catch it on accident because you have good
Hmm.
operational
Hmm.
processes,
Yep.
which usually the answer to that question is going to be no, just because
Yeah.
like there's the bajillion variables. Right.
Yeah,
And
but like for me and for us at TICKR, most of the clients we work with have nothing in place, right?
yeah,
Or that, or they the way they forecast is they look at last year's values and they just roll them forward to
20%.
this year. Yeah, exactly. And sometimes that works. A lot of times it really doesn't.
Yeah, it's also depend. The CPGs have an interesting thing because it's the more established the CPGs,
Hmm.
they are protecting their market versus growing their market. So
Right.
like Procter and Gamble, Coke, etc., right?
Hmm.
They're about maintaining their market share more than
Hmm.
anything.
Hmm.
More profit usually comes from different campaigns or new SKU kind of thing.
Right.
But like from
Right.
a market share perspective, they're not moving that much because the Coke
Right.
versus Pepsi, right?
Right.
Like people have their opinion about what they like, and that's pretty
Hmm.
much staying the same. And
Hmm.
except for new markets like Coke and Pepsi internationally
Yeah.
did a bunch of stuff
Hmm.
50 years ago or whatever.
Yeah.
And so like, for those big CPGs, market
Hmm.
protection is or
Hmm.
brand
Hmm.
management is like the primary thing they do. But then you
Hmm.
got these up and comers, and so yeah, they
Hmm.
can get 20% growth
Hmm.
just through marketing,
Yeah.
basically.
Yeah.
Whereas like the other CPGs got to, like the big CPGs got to do different things to
Hmm.
have that sustained growth that's
Yeah.
expected for publicly traded companies. Another thing, I've worked with some CPGs in the past and talked to some people who are really interesting in like their
Hmm.
business acumen about the problem. They can see that there's like brands that are going to take off,
Hmm.
yeah,
Hmm.
do an acquisition and then put like the force of the major
Hmm.
CPG's marketing
Hmm.
capabilities behind
Hmm.
it
Hmm.
and really just like dominate
Hmm.
within that new sector very
Yep.
rapidly because they
Hmm.
have all the processes to support that marketing capability.
Hmm.
Whereas like a small company, unless they've done it before as a
Hmm.
group, like they have to learn those lessons. And so
Yep.
the machine can help take these brands like
To the
way
next level.
farther. There's a lot of things there with like justifying the value of an acquisition as well.
Hmm.
Has TICKR done anything to help with like evaluation of acquisitions at all or not really?
Like evaluating how effective or how like whether a company actually got the value they thought they would get out of an acquisition. You're suggesting that when a company gets bought, you then figure out a way.
Or during due diligence, right? Like
Yeah.
during the due diligence, can you do some like forward
I'm
capacity planning, forecasting based
I'm
on?
I'm sure there is, especially using some type of language model as an assistant to go collect data and look at historical patterns, stuff like that. I'm sure there's definitely a path forward for use cases like that. I think in this there's a world of generative AI. I'm very bullish. I think almost everything will be possible, and a lot of business use cases and processes will be automated in the next 5 to 10 years. So it, that sounds like a kind of a moonshot, but I actually think it is possible.
I
So,
think that like the extremely repetitive and manual processes that
hmm.
are white collar in a
Hmm.
sense or at the computer are going to
Hmm.
be automated. It's where there's like a lot of branching
Hmm.
or it's where that people don't even do it because the amount of branching is so large, like
Hmm.
the product
Hmm.
categorization
Hmm.
problem that we
Hmm.
talked about,
Hmm.
right? Like, because people have been needing to do that for a long time, but they
Hmm.
just couldn't. Like, we got a use
Yeah.
case where it's like millions and millions of job descriptions, right?
Hmm.
Like, people are not going to go through that and
Yeah.
extract out the salaries or the
Right.
locations
Right.
and things like
Right.
that. Yeah,
Right.
you try, but like,
Yeah.
you're not going to do it. Yeah,
Totally.
so there's like two sides of that. There's like things that like nobody would even do before because it just didn't
Hmm.
like
Hmm.
economically you couldn't make it make sense.
Yep.
And then there's like the super repetitive, like
Hmm.
think a lot of data entry type
Yeah. A lot.
stuff.
A lot of data entry type stuff, a lot of things you might be doing in an Excel file. Like, I do think a lot of data science is going to get automated. I think the language models are going to be able to reason, as well as like somebody with a PhD in economics or somebody who's very specialized in causal inference, things like that. I think we're not there yet, but they will be able to do that. I do think there's a space of problems that will be solvable, but aren't solvable right now because there's no data, because people haven't thought about solving these problems. So, like the one we're hearing about a lot, and it's a little more high level, but is like agentic paradigms, agents, right? That's like all people are talking about for solving very complex reasoning tasks, but there's no data to one really benchmark agents yet. I know Scale AI is working on some. I'm sure there are some others. There's the really easy things to automate, the things that there's not that much data on yet or no data, and then there's the other space that probably won't be
Yeah.
automated.
I'm less bullish on the agentic approach because there's interfaces. Anytime you got interfaces, you got complexity. The more complexity,
Right,
the more
right.
problems.
I don't think we're there yet, but I think there is, just like with other aspects of language models like chain of thought reasoning or in context learning, or you could maybe even consider RAG as an emergent paradigm, even though it's been around since a lot of these have been around since like 2020. I do think there's emergent behavior that has been shown from agents, but I think it's all in really constrained like cases, right? When you deploy them, it's just it doesn't work.
Yeah. For CPG organizations evaluating TICKR, what are the
Mhm.
pain points it solves? In
Mhm.
other words, what technical or operational challenges does TICKR address that these organizations struggle with?
Yeah. I'll bring it back to something I said earlier. It really comes down to they are unable to save the money and time that they want with their current, teams. So we come in and we automate processes for them. We improve their forecasting and business planning and any other data science solutions we can build on top of their data to make them more efficient, more scalable, and save time and be able to focus their efforts where they want to focus their muscle, basically.
Yeah, I would also argue time, right? Like
Hmm.
not just saving time, but also time to value or time to market for some of
Right,
the things, right?
right.
Because maybe with an evaluation, there's something like a reason they're talking to TICKR, right?
Hmm.
And it's the fact that you're able to stand up a solution because you're already
Hmm.
integrated with the data
Hmm.
providers. And I'm
Yeah,
guessing a month to 3 months, right? Like one
yeah.
quarter deliverable or
Hmm.
within a quarter is
Yeah.
pretty strong statement.
I would say for a lot of our generative AI, especially generative AI solutions, because we've trained a lot of the models already, like they come to us with a problem. As long as it doesn't require any additional R&D, it's like a week for us to start flowing data into their
Yeah.
system, giving them predictions. And really that speaks for itself. They start seeing the value instantly, and then
Yeah. So from a platform play, you're able to get stuff running with
mhm,
less than a month, basically,
mhm,
unless there's an R&D effort that's required
mhm,
because the problem statement's like new.
exactly.
Cool. All right. So where can people learn more about you and TICKR?
Just go to our website, ticker.com. We also have a blog where we talk about the research we do. It's not exhaustive, but it's some of the things we do on the side while working for clients and experiments we make. And then if you're interested in potentially a career at Ticker, just go to our careers page. We're always hiring AI scientists, data scientists, engineers.
All right, Sam. Thanks for coming on. Hope you have a good one.
Thanks, James. See you later.
That's it for this episode of Data BS. If you enjoyed this episode, make sure you subscribe wherever you listen to your podcasts and not miss the next one. This episode was sponsored by CorrDyn, a data consultancy that helps organizations unlock the power of their data. If you have a data challenge, we can help. Visit CorrDyn.com, CorRDyn.com, to learn more. See you next time.